Hello class, and welcome to today's algebra lesson, which is about multiplication properties of exponents. By the end of today's lesson, you will be able to use multiplication properties to simplify expressions with exponents. So the first thing we want to talk about is what is an exponent. So an exponent is anything written in a format where we have a base, so the number that is being multiplied, and then the exponent, the value or the number of times that you are going to be multiplying it. This whole thing all together is called a power. So when we have a base number raised to an exponent, we are talking about a power. When we are simplifying powers, there are 4 rules we want to make sure we cover. We're going to talk about the first 2 in this lesson and then continue on to the next couple in the next couple of lessons. So the 2 focuses for today is that each variable appears exactly once, and then that there are no powers of powers, so that there are no double exponents in our properties. So the first rule that we are going to talk about is called the product of powers. This means that when 2 powers are being multiplied and they have the same base, you are going to add their exponents. So, for example, we have b to the 3rd times b to the 5th. So what does this actually mean? B to the 3rd is saying b times b times b, and then we're multiplying that by b to the 5th, which is b times b times b times b times b. Notice then we have 1, 2, 3, 4, 5, 6, 7, 8 b's being multiplied. So the total here would be b to the 8th. As it indicates in the rule, instead of having to write this out every time, you can take a shortcut and just add the 2 exponents. So we've got 3 plus 5, which is going to give you b to the 8th power. So that first example was just doing one simple problem where we were only dealing with one variable. Now we're going to expand on that rule as we keep going. When you are simplifying these longer expressions, you want to start with the coefficients in front. We're multiplying, so I'm going to take -4 times -6, which is going to give me a positive 24. Then I want to move on to my variable. In this first expression, I've got a single r, or r to the 1st power, and in the second one, I've got r to the 5th power, aka 5 r's being multiplied. If I have 1 from the first, multiplied with 5 from the second, I'm going to add my exponents, and that gives me r to the 6th power. Then I move on to my next variable, which is x. 2x's being multiplied in the first part, 2x's being multiplied in the second part, which gives me a grand total of 2 plus 2, or 4 x's being multiplied. And then I have d to the 3rd, so d times d times d, times d to the 1st, just one more d in that second expression, giving me a total of 3 plus 1, or d to the 4th power. So our coefficients, the numbers in front, you multiply as regular. The exponents you go through and add for each individual variable. So now instead of having r show up twice, it shows up once, x shows up once, and d shows up once. So each variable is only shown one time in our final answer. Go ahead and try this one on your own. Multiplying -5 times 7 gives you the -35. Adding up your exponents gives you a to the 10th and b to the 14th. Our next rule is called the power of a power rule. This means that when there is a power raised to a second power, so there's 2 exponents, you are going to multiply them. In this case, I have b to the 3rd to the 5th power. So I've got b to the 3rd, and I have that value 5 times because it's b to the 3rd to the 5th power. So what that means is 3 b's with another 3 b's with another 3 b's, and then that pattern repeated 2 more times. So notice, when I write this out the long way, I've got 3, 6, 9, 12, 15 B's as the answer. Or once again, you can follow the rule and take the shortcut, which is to multiply the exponents to get your answer. I just want to note real quick, the first rule, which was the product of a power, notice we had 2 separate bases with 2 separate exponents. And that is when you added, giving you b to the 8th power. In this case, with the power of a power rule, it is a single base with 2 exponents. So 1 base with 2 exponents. That's when you should be multiplying the values. So 2 bases with 2 exponents being multiplied, that's addition. 1 base with 2 exponents, that's when it's going to be multiplication. So in this case, I've got c to the 2nd, to the 5th, to the 4th. So I'm going to work from the inside out, and I'm going to solve c to the 2nd to the 5th first, which is going to give me c to the 10th power, and then that still needs to be raised to the 4th power, giving me a final answer of c to the 40th power when I simplify all my powers of power. Go ahead and try this one on your own. So simplifying, 3 times 5 is 15. Raising that to the 7th power gives you h to the 105th power. The last rule that we're going to look at is the power of a product rule. This says that if you are finding the power where there are multiple bases, so instead of just having one thing inside the parentheses, there is a coefficient and a combination of variables inside, you're going to raise each individual part, each component, to that power. So this is our distributive property rule for exponents. Why does this happen? So if I look at this first part, I've got negative 2xy to the 3rd, and I have that 5 separate times. So that's what it means to be raised to the 5th power, is I have that expression inside the parentheses. I have that occurring 5 separate times that need to be put together. So then when I simplify that, notice I've got negative 2 times negative 2, which is 4, times negative 2, which is 8, times negative 2, which is 16, times negative 2, which gives us a negative 32. Then I go through with the x's. X times x is x squared, times another x is x third, times another x is x to the 4th, times another x is x to the 5th. Then I've got 3y's times another 3y's, which is 6, times another 3, which is 9, times another 3, which is 12, times another 3, which is 15. So once again, you can take that shortcut by just distributing. So there was negative 2 to the 1st power, there was just 1, and x to the 2nd power, the 1st power. So when you would distribute, it'd be negative 2 to the 1 times 5, which is 5, x to the 1 times 5, which is 5, and y to the 3 times 5, which is 15. If you are doing a product of powers and there is a coefficient in front, you do need to simplify to that final answer so it is just one singular coefficient. So in this case, the negative 32, instead of having the coefficient written as a power. So going over another examples of these, I'm going to go through and I've got 3. I've got one of those to start. I've got 1x, I've got y to the 2nd, and z to the 3rd. So I'm going to distribute my power to each of the other 4 powers inside. So I would start with 3 to the 1 to the 9th, which is 3 to the 9th, x to the 1st to the 9th, which is going to give me x to the 9th, y squared to the 9th, which is going to give me y to the 18th, and z cubed to the 9th, which is going to give me z to the 27th. Now, as I said on that last slide, we need to solve any coefficient powers. So 3 to the 9th power is going to give you 19,683. Then we've got x to the 9th, y to the 18th, and z to the 27th for our final answer here. Go ahead and try this one on your own. So we distribute that 4, giving you 4 to the 4th, h to the 12th, j to the 4th, and k to the 8th. And then you have to simplify your coefficient power, giving you 256, h to the 12th, j to the 4th, k to the 8th. Putting it all together, if we have multiple things happening, we want to simplify each separate expression first. So I look at 3xy to the 4th, nothing to simplify inside, and there's no exponent on the outside. So that's going to stay put. So we got 3xy to the 4th. Then when I come over to my next expression, I've got multiple powers of powers. So I'm going to work from the inside out. So I've got -2, and then I'm going to distribute that in. So I've got -2 squared, and then distribute it to the y as well. So then I have y to the 10th. And that whole thing is still to the 3rd. Because I have a power of a power still, I'm going to go ahead and repeat that power of a power step. So the first part stays the same. Now I'm bringing that 3 as my power in. So I've got -2 to the 6th power and y to the 30th power. Then I want to simplify that coefficient part. So I want to solve 2 to the -6th power. And when I do that, that is 2 times 2 times 2 times 2 times 2 times 2, which is going to give you a positive 64 y to the 30th. Now I can go through and do my multiplication of powers. So 3 times 64 is going to give you 192. X times, no x's in the second one, stays as just x. And then y to the 4th times y to the 30th is going to give you y to the 34th. So your final answer is 192x, y to the 34th. Go ahead and try this one on your own. So we do the power of a power to the first one and a power of a power to a second one, simplifying those coefficient parts in the front, and then multiplying those two values together. You get 144a to the 4th, b to the 10th, c to the 2nd. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.